Okay, hello everyone. Today we're looking at nth roots and negative and fractional exponents. All right, again, the exponent is the power it's raised to up here. And we looked at the radical before. Well, we just looked at square roots. But we can be a cube root or a fourth root or a fifth root and stuff like that. All right, and this is a different way to write them. Instead of using the radical sign, we use a fraction sometimes like that, 1 over n. All right. As today's objective, there's a few. We want to convert from radical to exponential form. We want to be able to simplify a fractional exponent. And we want to solve just a one-step equation with a fractional exponent. All right, today's essential question. How are exponents and radicals used to represent roots of real numbers? Today is a lot of formatting, okay? Just use your calculators, guys, or use Desmos, it works. Right, we're going to write equivalent expressions is kind of what we're doing here. And you can kind of see one right here. If it's m raised to the power of a over b, well, what does that mean? The b, the bottom, is the root. The a, the thing on top, is the exponent you're raising to the power of a. M times itself a times. Just a quick review, you guys. Multiplication, it's just a shortcut for repeated addition. Rather than just say 3 plus 3 plus 3 plus 3 like that, we just say 3 times 8. Okay? And exponents are just a shortcut for repeated multiplication. Rather than just say 3 times 3 times 3 times 3 like that, or just to write it out. We don't want to do that. We just write 3 to the 8th power. All right? It's like a shortcut is all it is, okay? And guys, subtraction, of course, that's the inverse operation of addition. And division is the inverse operation of multiplication. Guys, the inverse of exponents is to find the root. All right, finding the root is the inverse operation of raising something to an exponential power. So if you want to undo a square, you take the square root. Right? The same for a cube. If you want to undo a cube, all right, like here it says 7 cubed is 343. 7 times 7 times 7. So if I say, what's the cube root of 343? Well, that equals 7, okay? It's the inverse operation. All right, again, guys, this little square root sign, the radical sign with the n there, that indicates an nth root. That's known as the index or the root. All right, it sits right there. Again, the radical sign is the square root sign, and the radicand is the number that's inside in the house, okay? The index, it's not really outside the house. I mean, it is, but it just kind of sits right here, okay? That's the index. Sometimes there's a number in front of that as well. Guys, we can rewrite radical expressions as a fractional exponent. In other words, rather than write it as the root of n like this, like a kind of the nth root of a, we can write it like this: a raised to the 1 over n power. That means root. All right? This is a very important, these three right here, to understand the equivalent expression here. When we say a raised to the m over n power, that means the m is the exponent we're raising it to the power. The n is the root. All right? Again, we can rewrite a radical expression with a fractional exponent. This is an example. Okay? The root or the index is the denominator. All right? The exponent on the radicand is the 2 on top. Guys, again, you can always use your calculator too. just take 7 raised to the 2/5 power. Just put in the calculator, or you can use Desmos as well. Also, y'all remember that the cube root of a negative number is a real number, and it's negative. Right? The cube root of negative 27 is negative 3. Because negative 3 times negative 3 times negative 3 is negative 27. Y'all, that works for any odd root. It won't work for a square root or a 4th root or a 6th root. It won't work for that. All right, but a cube root or a 5th root, it will work. All right, I got another example here. The cube root of negative 125. It actually equals negative 5. It's okay. All right, you can take the cube root of a negative number. Okay, y'all, a negative exponent. Sometimes the exponent up here is negative. Y'all, that does not actually mean negative. What it means is reciprocal. Something raised to a negative exponent just means 1 over that number. That's what it means. Okay, so here if 2 is raised to the negative 3rd power, that actually means 1 over 3 cubed, or 1/8. All right, 2 times 2 times 2 is 8. That's what that means, guys, all right? It doesn't really mean negative 1/8. It just means 1 over. If we wanted to make this a negative, we put the negative in front. Again, guys, a negative exponent does not mean negative. This is just some examples. Again, 1 over this radical expression is the same as 1 over this fractional exponent, which is the same as the base of 5 with a negative exponent here. Okay? Now, if we want to solve an equation with a fractional exponent, something like this. All right, 16 equals x to the 3/2 power. Okay, what do? Guys, you raise both sides of the equation to the reciprocal of the power. Because 3 over 2 times 2 over 3, that just equals 1. That's how you get this to equal just x. But because we raised this side to the 2/3 power, we have to raise this side to the 2/3 power. So you can put that in your calculator, okay? You get 64. All right, 16 squared, and then take the cube root of that. You get 64. All right, guys, just some kind of a summary here. Again, you're going to have positive exponent, means 5 times 5 times 5, all right? That's what an exponent does. A negative exponent, again, means reciprocal. So it's just 1 over that number is what it means. Guys, a rational exponent, again, 1 over n just means the nth root. But when it's a fractional exponent, the m is what we're raising it to the mth power. The n is the root. And also just to remember, guys, 0 as an exponent is always 1, regardless of the base. Whatever the base is, if it's raised to the 0 power, it equals 1. All right, anything raised to the 0 power is 1. All right, again, here's some more examples if you want to take a look at it. And guys, again, another little summary is pretty good. And you can take a look at that. I've gone through all of this already. All right, show some examples right here for you. So I'm running out of time here, so I need to stop. Guys, you can take a look at that and rewind it if you want, or stop it. Guys, please complete the vocabulary assessment and the notes assignment, and then participate in the discussion question. That's all in the green folder. We'll look at them in class. In the second Zoom meeting, we'll go over the summary now, which is in the orange folder. In fact, guys, we might look at the vocab real quick too. All right, but we'll definitely do the summary. All right, here's today's vocabulary questions. All right, question number 2 is actually repeated, so it's just 2 questions you have to select there. Identify the index and select 3 equivalent expressions. All right, that's it, y'all. Thank you.